Okay, let's dive right into this. Welcome to today's explainer, where we're jumping straight into a real-world Haskell refactoring journey. You know, if you've ever worked on a growing code base, you totally get that the architecture that got you off the ground, well, it rarely survives contact with new feature requests. Functions just get bloated, argument lists stretch way across your screen, and things start to feel, honestly, pretty messy. So today, we're looking at a super practical, step-by-step example from a developer named Ang, who recently documented a highly relatable refactoring process. We're going to see how taking a scattered approach to data and consolidating it into a shared record type can literally, instantly streamline your code.
Look at this quote directly from Ang's developer notes. "I've been passing arguments from the args data type as individual parameters, which is getting a bit tedious." Man, tedious is absolutely the key word here, right? It's just a universal pain point in software engineering. You start with a simple helper function, maybe it takes one or two arguments. Then, oh, you need a file path. Then an export format. Then a verbosity flag. And before you know it, you are juggling half a dozen parameters every single time you call that function. It clutters your logic, it definitely increases the chance of making a silly typo, and frankly, it just makes the code a total chore to read and write.
Section 1. The tedious argument problem.
Let's really map out the friction that was happening in this Haskell project right before the refactor. Here are the exact data fields Ang was dealing with. This is the args data type, which essentially holds the entire configuration for a command line tool. We've got 5 specific fields: input path, which is a file path, output format, which is an export format, verbosity as an integer, debug mode as a boolean, and open after, which is another boolean. Now just imagine having a helper function somewhere in your app that needs to know the format, the path, and maybe the debug status. If you're passing these individually, you're manually unpacking these fields and feeding them one by one into your function. It's incredibly repetitive, and as we all know, repetition in code is usually a giant flashing signal that it's time to refactor.
Section 2. Centralizing the args type. To completely eliminate this friction, we need a structural shift. So the crucial point is that we need to execute this refactor in 2 distinct phases to keep our application running smoothly. As outlined right here, step 1 is moving the args data type into a dedicated shared module called sx2ebook.types. Step 2 is going back into our application logic and updating our primary helper function, convert to ebook, to actually utilize this new centralized structure. It's a classic separation of concerns. We're moving data definitions to a common area so the rest of the application can safely depend on it without creating any nasty circular dependencies. Looking at the execution of step 1, Ang moved the args type right into the access to ebook.types module. But, and notice an absolutely crucial detail here, we aren't just putting it in the file. We're explicitly exporting args and its fields from the module. In Haskell, you do this by adding args and then 2 dots in parentheses to your export list. Actually, those 2 dots inside the parentheses are incredibly important. They tell the Haskell compiler to export the args type constructor along with all of its internal record fields. So now the whole shebang is available. Any other module in this project can just import access to ebook.types and get instant, full access to the entire configuration structure. Section 3. Updating the helper function.
Okay, we've built the foundation, and now we actually get to clean up the messy code that started this whole endeavor. And this brilliantly illustrates the immediate payoff of our refactor. Just look at the before. Our convert to ebook function had a really messy type signature. It took an export format, then a file path, then a list of tokens. It was explicitly, tightly tied to those individual pieces of data. But check out the after execution. The signature simply takes the whole args record and the tokens. That's it. We've collapsed multiple configuration parameters into a single cohesive unit. It is infinitely easier to read at a glance.
But, the real benefit here isn't just aesthetic, it's absolutely about future-proofing. This function call won't need updating every single time a new field is added to the args type. Think about that for a second. If Ang decides tomorrow that the app needs a brand new configuration flag, let's say a force overwrite flag, they just add it to the args record over in the types module. The type signature for convert to ebook, it doesn't change at all. The function just receives the updated record automatically. We've significantly lowered the maintenance burden of the entire codebase.
Section 4. The remaining brittleness. However, we do have to pause right here. Because as satisfying as that refactor was, pulling back the curtain reveals we've actually introduced a really subtle new vulnerability into our code. Now, what's really interesting about this slide is how the function actually extracts the data it needs from that single args record. Inside the convert to ebook function, Ang uses pattern matching to grab the file path and the format. It looks like this: args, path, fmt, and then 3 underscores.
In Haskell, those underscores are wildcards. They basically mean, hey, I know there's data in these positions, but I just don't care about it for this specific function. But look closely at what's happening. The function is pulling out path and FMT based purely on the order they were defined in the original data type. It's relying completely on position.
And this brings us to a literally vital concept in software engineering: brittle code. Brittle code is an architecture that easily snaps and breaks due to really minor future changes. By using positional pattern matching, our code is now highly brittle. Remember how we just said adding a sixth field to our record is great because the function signature doesn't change? Well, if we do add that sixth field, our pattern match of args, path, FMT, and 3 underscores suddenly completely breaks. It's only expecting 5 fields, not 6. The Haskell compiler is going to throw an error immediately. We solved one problem with our function arguments, but we've accidentally created a hidden maintenance trap right inside the function itself.
Which leaves us with this absolutely crucial question to end on. If adding a new field breaks our positional matching, how do we fix this brittle code in the future? Ang smartly noted in the devlog that this will be tackled in a future update, hinting at much more flexible, advanced ways to handle records in Haskell, maybe using things like record wildcards or named field puns to match fields by their actual names instead of their strict, rigid order. But for right now, we've taken a massive step forward in code cleanliness, while definitely leaving ourselves a fascinating challenge for next time. Keep this exact problem in mind the next time you're extracting data from a record in your own projects. Thanks for joining me on this explainer, and keep learning.